Betelgeuse is a red giant star assuming you put it where the sun is, it would stretch out to the circle of Jupiter. This tremendous, entirely temperamental star is going to detonate. These blasts are among the greatest eruptions of radio energy in the whole universe, producing more energy than a billion suns. Are you prepared for what is going to happen? Betelgeuse, a monstrous red star, one of the nearest stars to Earth, has as of late gone through striking, diminishing that has caught attention and blended feelings worldwide. This diminishing has led to speculation among astronomers and the public about its expected ramifications. Some researchers believe the strange behavior could be a forerunner to a cosmic explosion, a destructive event that happens when a star depletes its atomic fuel and implodes under its own weight, prompting an enormous blast. Such an event raises concerns not just among established researchers, but additionally among the general public, as it offers conversation starters about the expected effects on our own planet. Betelgeuse is a noticeable part of the constellation Orion, easily recognizable in the night sky due to its unmistakable shape and brilliant stars, also referred to as Alpha Orionis. It holds the title of the most brilliant and largest star in this constellation. Ongoing information gathered by NASA's Hubble Space Telescope alongside observations from various observatories has shown that Betelgeuse encountered a huge mass infusion in 2019. This behavior is extraordinary for a star of its kind and has provoked the interest of astronomers worldwide. While coronal mass ejections are a common event in our own sun, the unique event seen in Betelgeuse adds an interesting layer to how we might interpret celestial life cycles and the dynamics of monstrous stars. The distance to Betelgeuse remains a subject of discussion among astronomers. Some estimates propose it is farther away, while others indicate it could be as close as 724 light-years from Earth. Accurately determining the distances of red giant stars like Betelgeuse is a perplexing test due to their tremendous distances and unique attributes. Betelgeuse stands out as one of the most brilliant stars visible in our night sky, flaunting a radiance roughly 1,000 times more significant than that of the sun. However, this unimaginable brilliance comes at a tremendous cost. Betelgeuse drinks its atomic fuel at an accelerated rate, hurrying the inevitable finish of its celestial life. Eventually, the star will deplete its fuel supply, prompting a dramatic breakdown under its own gravitational pull, potentially resulting in a cosmic explosion that could give birth to a neutron star or even a black hole. Should our current astrophysical speculations turn out as expected, this raises a significant inquiry. Does Betel represent a danger to Earth if a cosmic explosion were to happen only a few light years from our planet? The outcomes could be annihilating. The blast of a supernova can discharge an extraordinary amount of light, possibly matching that of a whole galaxy in this way, regardless of whether Betelgeuse is somewhat far off like the star Alpha Centauri. The impacts of its cosmic explosion could be significant and expansive. Strikingly, since the last cosmic explosion seen in our own universe in 1604, humankind still hasn't witnessed such an event locally. However, a remarkable cosmic explosion happened in 1987 in the Large Magellanic Cloud, found 169,000 light-years away. While that event had massive impacts, it represented no immediate danger to Earth, serving as a sign of the scale and expected effects of such galactic events. The concept of a risk zone encompassing a typical cosmic explosion is fascinating and could have serious ramifications for life on the planet. If a cosmic explosion were to happen nearby, by its essential to understand that in the grand cosmic scheme, cosmic explosions are relatively small events compared to gamma bursts, which are vastly more powerful and represent a different kind of danger. Supernova can have wrecking impacts, capable of crushing biospheres and immersing worlds with deadly radiation. For instance, a specific kind of cosmic explosion can lead to the obliteration of a planet's ozone layer, leaving it vulnerable to the unforgiving radiation of the universe long after the blast has occurred. This possibility was featured in a recent study that presented new potential risks related to gigantic stars that end their lives in a spectacular style. When giant stars detonate in a cosmic explosion, they can reach some of the most noteworthy luminosities known in the universe. In fact, the brightness of a solitary cosmic explosion can eclipse the combined brilliance of many billions of stars. This raises the question of what the ramifications would be if Betelgeuse were to undergo such a blast of a cosmic explosion to happen. Betelgeuse would become the second most brilliant object in our sky after the sun, surprisingly, despite the distance separating it from us. Betelgeuse, which shines more brightly than a full moon, would become visible during daylight hours. The sheer force of the blast would result in a display so stunning that shadows would be projected even in complete darkness. Such a scene would be both awe-inspiring and frightening, illustrating the raw power of colossal events. While the visible light emitted by a mic explosion is indeed tremendous, it is only a part of the total energy produced during such an event. Although high levels of apparent light can present dangers such as temporary blindness, the greater concern lies in the high energy radiation produced alongside the visible light. This radiation often manifests as X-rays and gamma rays, which can have broad consequences. One of the most significant risks posed by this high energy radiation is its ability to catalyze the consumption of oxygen from the ozone layer that safeguards our planet from destructive solar radiation. Without a healthy ozone layer, life on Earth's surface would be exposed to intense ultraviolet radiation from the sun, potentially leading to mass extinction events. In the aftermath of a cosmic explosion, various dangers arise over time. In the first moments following the blast, the intense radiation presents imminent risks. However, over the long term, massive beams of subatomic particles pushed to near light speeds begin to invade the solar system. These cosmic rays can break ozone layers and cover the Earth's surface with harmful radiation, exacerbating the dangers posed by the initial blast. Furthermore, cosmic rays carry with them a large portion of the total energy produced by the cosmic explosion, and their long-term effects can linger for hundreds of years. There is evidence suggesting that such events might have impacted Earth in the past. For example, raised levels of iron 60A, radioactive isotope created in Supernova, have been found in seafloor silt and lunar regolith. This finding suggests that Earth may have been affected by cosmic explosion ejecta in relatively recent geological history, perhaps within the last few million years. Astronomers have already inferred that there are currently no nearby cosmic explosion candidates that pose an immediate danger to life on Earth. Based on our understanding of the risks associated with gamma rays and cosmic rays, however, ongoing research has revealed additional potential risks related to specific types of supernova. These supernova can emit long-range lethal radiation that poses a greater risk to planets like our own. The mechanism behind this involves a star nearing the end of its life, surrounded by a massive plate of material. When the cosmic explosion occurs, a shock wave is created, striking this plate and causing it to become incredibly hot, thus producing a significant amount of high-energy X-ray radiation that can travel vast distances. Through space SP, the most luminous X-ray, supernova have the potential to deplete a planet's ozone layer by as much as half, creating conditions that could trigger an extinction event within a range of about 150 light-years. Fortunately, at this point, no candidate X-ray supernovae have been identified in the immediate vicinity of Earth. However, this research has led to new insights into the cosmic habitable zone, the region within galaxies where conditions are favorable for life. The findings suggest that this habitable zone might be subject to additional constraints. Specifically, the outer regions of a galaxy don't have sufficient star formation activity to create the elements necessary for the formation of rocky planets. Meanwhile, the inner regions where stars form and die at a faster rate present their own risks. Continuous cosmic explosions in these areas can illuminate the surrounding space, increasing the risk for any potential life that might exist there. New research suggests that the inner boundary of the cosmic habitable zone is likely located farther from the galactic center than previously thought, reshaping our understanding of where life might potentially thrive. So what will Betelgeuse's cosmic explosion look like from Earth? While Earth's biospheres will probably remain unaffected, the scene itself will be hard to ignore. According to scientists, Betelgeuse will continue to shine brightly for more than 90 days, following its blast, reaching a glow almost equivalent to half that of the Moon, multiple times fainter than a full moon. Essentially, it will appear as a bright point overhead, serving as a beacon that could be visible even during the day. Its striking brilliance will captivate anyone who looks up, casting shadows in the night. The celestial event will undoubtedly be a source of interest for everyone on Earth, as the cosmic explosion remains visible to the naked eye for many months, its remnants slowly fading. Researchers continue to study Betelgeuse. They are uncovering more about the life cycle of massive stars and the processes that lead to their hazardous endings. Understanding these vast phenomena is crucial for gaining insights into the evolution of our universe and the formation of elements during a cosmic explosion. Additionally, the light produced during these events creates a huge range of heavy elements like gold, silver, and uranium, which are created in the extraordinary heat and pressure of the blast. This process, known as nucleosynthesis, plays a fundamental role in enriching the interstellar medium with the building blocks of life, which can later be incorporated into new planetary systems. This cosmic cycle of creation and destruction adds to our appreciation of the universe, highlighting the deep interconnectedness of all things. While a cosmic explosion of Betelgeuse magnitude might be many light years away, it serves as a reminder of the powerful processes that shape the cosmos. As the life cycle of Betelgeuse unfolds, it offers an important lesson about the universe's impermanence and the continuous process of cosmic renewal. The star's eventual death, as spectacular as it may be, will contribute to the formation of new stars, planets, and possibly even life forms elsewhere in the cosmos. When Betelgeuse explodes, it will release vast amounts of energy, including a flood of elements, into the surrounding interstellar medium. This influx of heavier elements like carbon, oxygen, and nitrogen will help seed the formation of future stars and planetary systems, influencing the chemistry of galaxies for millions of years to come. The remnants of Betelgeuse explosion will be scattered across the cosmos, forming what is known as a supernova remnant. Over time, this nebula of gas and dust will spread outward, enriching the nearby interstellar medium and potentially fueling the next generation of stellar bursts. The shock wave from the explosion will also trigger the formation of new stars from the dense pockets of gas that accumulate in the wake of the blast. The cycle of death and rebirth is a key aspect of stellar life cycles, the formation of elements and the potential for life elsewhere in the universe. It will continue to fuel humanity's quest for knowledge as we reach for the stars and seek to understand our place in the vast, ever-changing cosmos. Betelgeuse, eventual supernova, will also serve as a reminder of the fleeting nature of all things. Despite its immense size and power, even a star as massive and brilliant as Betelgeuse must eventually meet its end. This humbling truth encourages us to appreciate the time we have and the life we share on our own planet, while also reminding us of the vast forces that govern the universe, shaping it in ways we can only begin to comprehend. In the end, Betelgeuse cosmic explosion will mark the conclusion of one chapter in the life of the universe and the beginning of another as the universe continues its vast, unceasing transformation. Betelgeuse's final act will remain etched in the fabric of time, a testament to the dynamic forces of creation and destruction that shape the cosmos. And though the explosion itself will not pose a significant threat to life on Earth, it will undoubtedly captivate our imagination and leave an indelible mark on our understanding of the universe and our place within it.